keep delving into chapter 9 here. We're going to work on finding the vertex of a vertical parabola. So we did that a little bit in the last video, but we're going to look at how to do this in a little bit more algebraic method, looking at the equation. We're going to look at graphing the quadratic function using the discriminant of the number to figure out how many x-intercepts there are, then using those quadratic functions to solve problems that are looking for a max or a min, and then we're going to graph parabolas with a horizontal axis. So we're going to look at flipping that parabola to the side. So when we're given the equation of a parabola, what we've been doing is we've been graphing it, looking at the graph, and then finding the vertex. What we want to do here is be able to find the vertex from just the equation. And so there are two ways to do this. We can use completing the square to get that nice factored vertex form, or we can use a formula that is derived from the completing the square process. Now, if you don't remember completing the square, you can definitely check out one of my other videos. I do have a video on completing the square on the YouTube channel. So if you search completing the square, you will find that. I also have a handout, so if you want to email me, I'm more than happy to send you that handout and share it with you. So when I'm looking at this equation, I want to find the vertex. I can complete the square, for which the first step is going to be to leave this space here. So I want to basically create an empty space, and I want to take the constant and leave it outside of the parentheses. Then I'm going to take the coefficient of x here, which is 4, and I'm going to take that value and I'm going to divide it by 2, and then I'm going to square that value. So that gives me 4 again. It's not always going to work out where you get 4 again. It's the same process though. The number divided by 2 and then square it. You add that value inside of the parentheses. And then to keep it balanced, I'm going to subtract that value outside of the parentheses. So 4 minus 4 is 0. So I really didn't do anything here that is not okay with balancing the equation. When I do that, notice that this parentheses will always factor to x plus or minus the value you found here, so before you squared. So 4 divided by 2 is 2, so it factors to x plus 2 squared. Now we know the vertex is going to be the opposite of the value in the parentheses, comma, and this is not opposite, it's exactly how it is. So that is how we're going to find a vertex using this form. Now, is this going to be the easiest form? Not necessarily. So let's look at completing the square with when we have a number in front of the x squared. So just bear with me. So what I'm going to do is I'm going to factor a 2 out so that I have x squared minus 2x. So I have to get the number in front of the x squared to go away. I'm going to take that linear term, so the number in front of x, I'm going to divide it by 2 and I'm going to square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. I'm going to add it. And then I'm going to do that weird thing where I'm also subtracting it. Then this information here is going to factor to x minus 1 squared, because what we found here was minus 1. So my vertex is going to be 1, negative 1. This is probably not the easiest method for most students. Most students are going to want to be able to use this vertex formula. So while I showed you the completing the square, because there are some students this really works well for, this is probably the space where you're going to be. So I want to take and do negative b over 2a. That's going to tell me my axis of symmetry as well as my x value in my vertex. Then I'm going to replace x with that value and get the f of that for the second one. So I know this looks more complicated, but I promise it's not. So let's look at how this works. First step is to define a, b, and c. So the number in front of x squared is my a, b is the number in front of x, and then c is the value that's added or subtracted. Watch how easy this is. Negative b over 2a is negative 3 over 2 times negative 2. There's my axis of symmetry. Done. 3/4 is my axis of symmetry, and it is the x value in the vertex. So to find the y value, you're going to replace every x with 3/4. Guys, do this in the Web 2.0 calculator. It's going to make your homework so much easier. You can type this in completely in one statement. Negative 2, open parentheses, 3/4, close parentheses, squared, plus 3. So you can type it in just like you see it, and it'll tell you the answer is 1/8. So you don't have to go through all of these little arithmetic steps. You can type it in right here, and it's going to give you 1/8. So you get 3/4, comma, 1/8. Was that not so much easier? Right? It's so much easier. So definitely that's the method where I suggest you live at. So to graph a quadratic function, we've kind of already looked at that in the previous section, but let's just define it. If the value in front of x squared is positive, it's going to open up. If it's negative, it's going to open down. So to find the vertex, I, again, think the vertex formula is the best way, I promise. Then we're going to find any intercepts by solving for where the equation equals 0 and plugging in 0. Then we're going to connect the dots and create a graph. So let's look at what this looks like. So we want to find the vertex, the axis, the domain, the range. I'm going to define A as 1. It opens up. So to find the vertex, I'm going to use the vertex formula, negative b over 2a. So I get x equals 3. That's my x-coordinate. To find my y-coordinate, I'm going to replace x with 3. I'm going to type that straight in the Web 2.0 calculator, and I'm going to get negative 4. So I know that my vertex is 3, negative 4. Now, to find the x-intercepts, I'm going to set the equation equal to 0, which is going to mean, so we're pulling back from that previous knowledge, you're going to either have to factor, do the quadratic formula, complete the square. That's how you're going to solve these. So I get that my x-intercepts are 5 and 1. To find the y-intercept, I plug in 0 for x. So I get 0 squared minus 6 times 0 plus 5 is 5. So I have my vertex, I have my intercepts. I'm going to put them on the graph. So by symmetry, 6, 5 would also be a point, because if this is my y-intercept and I have this axis of symmetry, then my reflection point is over here. I'm going to connect the dots, and there's my graph. So my axis of symmetry would be x equals 3, which is the x-coordinate of my vertex. My domain, it's a polynomial, negative infinity to infinity. My range is going to start at the vertex at negative 4 and go up. So remember, the range is going to be the y value, so negative 4 to infinity. It's always going to have a bracket on the number, always a parenthesis on infinity. So let's use the discriminant. The discriminant gives us some really, really great information. What is the discriminant? It is a portion of the quadratic formula, so it's the part underneath the square root. So if my discriminant is positive, we have 2 x-intercepts. If it's 0, we have 1 x-intercept. If it's negative, we have none. So what does that look on the graph? Well, these have 2 x-intercepts right here. These have 1. These have none because they never cross the axis. So that's the actual what it looks like we're doing. So I'm going to find the discriminant by finding A, B, and C. Then I'm going to plug into b squared minus 4ac. You can type this directly in the Web 2.0 calculator, but make sure you're using parentheses when you plug numbers in. So I plugged in negative 1, it goes inside parentheses. And I get 25. So my discriminant is positive, so I have 2 x-intercepts. Let's try it again. A, B, and C. Plug into the discriminant formula. Use parentheses around everything, type it straight into the Web 2.0, and you get negative 3. It's a negative discriminant, so there are no x-intercepts. Let's try it one more time. A, B, and C. Plug it in the discriminant formula. Enter that straight in the Web 2.0 calculator, and it's going to give you 0. 0 means 1 x-intercept. This is not too bad, right, guys? If we're using that vertex form, then that A, B, and C, we get the rhythm going from the quadratic formula, and it's not so bad. So what we want to do now is talk about, okay, well, what's a maximum and a minimum? Well, when we look at a parabola, we have either a maximum or a minimum, depending on how the parabola opens, up or opening down. So if we have 100 feet of fencing to enclose a rectangular area in a building, length times width is the area of a rectangle, we want to find the maximum area he can enclose. So x is my width, and I'm going to add my length, and I know that's 100. So I have 2x plus my length is 100, so my length would be 100 minus 2x. This is the toughest part of the question, and it helps if you draw that rectangle and you label it out. So my width is x, my length is 100 minus 2x, and you can kind of see how I drew this picture out. This is x. This would be 100 minus 2x. I'm taking away this side, and I'm taking away that side. I'm going to multiply the two together. I get a quadratic. I'm going to find the vertex. The vertex is the maximum or the minimum. I'm going to use that vertex formula, negative b over 2a. And that gives me the x-coordinate of 25. So once I see that that x-coordinate is going to be 25, I can plug it back in to get my actual y-coordinate out, just like we did for the vertex. And so I have 1,250. So my vertex is 25, 1,250. It opens down, which means that's my maximum. So the maximum area I can have is 1,250. 25 is related to the dimensions, not the maximum area. So we're always looking for the y value when we're using this process. So the width is 25, that's my x value. And if I want to find 100 minus 2 times 25, that's going to give me my length, and the dimensions my length needs to be. We can do the same thing with a rocket. Think about the way a rocket looks. It launches up in the air and then it curves back down towards Earth. So when I do that, I'm going to have a maximum height that it reaches and a number of seconds it takes to reach that height. I'm going to find the vertex. So that maximum is going to happen at that vertex. So I'm going to do negative b over 2a, and I get my t. That's the time that it happens, not the height. So if I wanted to know the height, I'm going to plug that back in, and I get 676. So it takes 6.5 seconds to get 676 units high in the air. So graphs with parabolas that have horizontal axes, the process is going to be very similar, except I'm going to have y's. But everything else kind of remains the same, okay? So in this case, h is swapped. It's outside the parabola, it's outside of the x squared, and k is on the inside, which should make sense because I swapped from x squared to y squared. And my axis of symmetry is now going to be y equals. So if I'm looking at this graph and I want to give the vertex, I'm going to go back here. So my x value comes from what's being added or subtracted outside the parentheses. My y value comes from what's inside the parentheses. So that would be negative 4 would be my x value. Negative 1 would be my y value. So notice this is still going to be an opposite situation here. It opens to the right. So if it's positive, instead of opening up, it's going to open to the right. If it's negative, it's going to open to the left. My axis of symmetry, instead of being the x-coordinate now, it's going to be the y-coordinate. And then I can create my table of values, and I can connect the dots. The domain is no longer going to be all real numbers because it's flipped sideways. So the domain is going to start at the vertex, and it's going to continue, and then my range is going to swap and be all real numbers. So I'm switching the x and the y in the equation, which is switching the values of my vertex, which is switching the axis of symmetry, and it also switches the domain and the range. Let's try one more. I want to give the vertex here. I don't have it in that nice vertex form, so I'm going to use the vertex formula, or I'm going to complete the square. You can do it either way. So I get 6, 1. And if you want to use the vertex formula, go ahead and give it a try and see how it works out. The axis of symmetry is the y-coordinate of the vertex. It opens to the left because it's negative y squared. So I'm going to plot my points, connect the dots. My domain is going to be negative infinity to 6. And then my range is going to be all reals because that's going to happen every time with a sideways parabola. Here is a quick reference. You might want to take a picture of the screen or copy it down on a sheet of paper so you have it. So you know what these graphs are going to look like. When you're in the lab, you want to make sure that you have the general shape of the graph in your mind before you start graphing these parabolas.